Hello and welcome to this video on the average rate of change. So when we're finding the average rate of change of a function on some interval of x, what we're going to do is we're going to look at the graph of that function, and we are going to look at the line that goes through the points on that graph. In this case, we're going to be looking at the function f of x equals x cubed minus 5x plus 8. And then we're going to look from x equal -2 to 4. So we're going to be looking at the point that is at x equal -2, and then x equal 4 is off the screen up here to the top. We're going to be looking at the slope of the line that goes through those two points. That is what the average rate of change is. And remember, our slope formula is y2 minus y1 over x2 minus x1. We know our x and we know our two x values, and we know our function, and we can use our function to find that y value. So the average rate of change formula is actually just a different way to look at the regular slope formula. The average rate of change formula that we normally use is f of b minus f of a over b minus a. So our x values are the a and the b that were given in the problem, and then the y value is going to be the function value at each of those points. Again, it does not matter, just like on the regular slope formula, it doesn't matter which one you call a and which one you call b, as long as whichever one you put first on the top is the one that you put first on the bottom. All right, so if we plug in, I'm going to go ahead, normally you have a be the smaller number, so I'm going to go ahead and plug in x equal -2 as our a and x equal 4 as our b. So f of b is going to be, if we plug in a 4 there, 4 cubed minus 5 times 4 plus 8, all of that is our f of b, minus, plugging in the -2, we get -2 cubed minus 5 times -2 plus 8, all over 4 minus a -2. All right, 4 cubed minus 5 times 4 plus 8 is 52. And -2 cubed minus 5 times -2 plus 8 is equal to 10. And then in the denominator, we get 4 minus a -2. That's the same thing as 4 plus 2, or 6. So 52 minus 10 is 42, divided by 6 gives us an average rate of change of 7. So that means if we were to look at that line that we were imagining on our function, it would have a slope of 7. Now we call that line the secant line. So we're going to do something very similar on this next example. We have f of x equals 7x minus 3. We're asked to find the average rate of change from x equals 6 to x equal 8, and then find the equation of the secant line from 6 to 8. So a secant line is the one where our slope is equal to that average rate of change. So we need to, in order to find the equation of a line, we have to know two pieces. We have to know a point, and we have to know the slope. The way we find the slope is we plug in f of b minus f of a over b minus a, where here I'm going to let a be my 6 and b be the 8. So if we plug, if we plug in 8 there, we're going to get 7 times 8 minus 3. And then if we plug in 6, 7 times 6 minus 3, all over 8 minus 6. Remember, whatever number we're plugging in here is going to match up with the number on the bottom. So if we plug in 8 there, that simplifies. It'll be 56 minus 3 will be 53. And then 7 times 6 is 42 minus 3 is 39. Sorry, just double checking my math there. 6 minus 8 gives us a 2. So 53 minus 39, I don't want to make a mistake, even if it's simple arithmetic, is 14 over 2. So we get 7 is our average rate of change. That's going to be our slope value. And then we can use either point, the 6 or the 8. What we see is this is our y value, or our function value at 8. And the 39 is our function value at 6. I'm going to go ahead and use that smaller one just because the numbers are smaller. But you could use either point and you'll get the same answer. So we have our point here. Our x value is 6 and our y value is 39. And then our slope is 7. So we get y minus y1 equals m times x minus x1. Distributing that 7, we're going to get 7x minus 42. And then if we add 39 to both sides, that's going to be a negative 3. And what we see here is that if you start out with a line, we started out with the line 7x minus 3, that's actually going to be your answer. Because any 2 points on that line are going to have the same slope. And then that starts out as a line. So if we have any 2 points on that line, any line that goes through those 2 points is going to have the same y-intercept. That will not always be the case, but it will be the case if what you start out with is a linear function. All right, I'll see you guys next time.